Hello students! Today, we will be discussing some of the basic programming concepts that you will be needing for particular computer applications that we will be covering in this course. But before that, I am Engineer Eldon de Padua, and I will be your lecturer for today's topic. In this lesson, you are expected to do the following. First, understand the fundamentals of computer programming. Second, identify the different programming paradigms. And lastly, know the functionalities of object-oriented programming. Before we proceed, let us first recall the definition of computer program to make sure that we are on the same page. If you can recall from your programming course, computer program is defined as a series of instructions written to perform a specific task for a computer. It is a series of instructions that dictate the manner of execution of a computer. To better understand it, remember that computers are dumb objects. Their capabilities are so dependent on what we instruct them to do. It's like teaching a friend of yours how to solve a simple math problem or instructing your younger sibling to buy groceries in the supermarket. You give them a detailed instruction to make sure that they would give you your expected output. On the same way, everything done on a computer is done using a computer program, and without programs, computers are useless. Speaking of computer program, some of you now might be starting to think about programming languages. What programming language should I be using? What programming language would fit best on the applications that we will be learning in the course, and so on. You need to understand that regardless of what specific programming language you will use, you must first understand the nature of the problem you want to solve and understand the nature or features of any programming languages. Here are the types of programming languages. First, we have machine languages or machine code. Machine code is the binary code that is used by the computer natively to perform operations. As a program, it is a set of instructions for a specific central processing unit that is used to represent operations and data in a computer. For example, binary code 10000001 is A, while binary code 10000010 is B. The second type of programming language is the assembly languages or assembly code. Assembly code is a low-level computer language that is specific to a particular computer architecture. It uses an English-like abbreviations and hexadecimal values to make complex instructions easier to write. For example, instead of giving the computer the instruction to load 61 hexadecimals into register AL by writing a series of zeros and ones or binary codes, you just simply write MOV space AL, 61H, which means move data, in this case 61 hexadecimal or 97 decimal, and store it to register or variable AL. In this type of programming language, we use another architecture-specific translator program known as assembler to translate the assembly code into machine language or machine code. On the other hand, the other type of programming language is the high-level languages. This type of programming language is the most widely used one in the present due to its ease of use and complex applications. It is a computer language whose instructions or statements correspond to several machine language instructions. Instructions in this language look like almost everyday English and contain commonly used mathematical notations which made programming significantly easier. For example, instead of using complicated assembly codes or machine codes in order to add numbers 4 and 6, we simply code sum equals 4 plus 6 in high-level languages. Pretty convenient, right? Meanwhile, codes in this language are being translated into machine language by using translator programs called compilers and interpreters. Can you remember one example during your computer fundamentals and programming course? If not, it's time for you to do a quick review of your notes. Now, let's take a look on the differences between compilers and interpreters. Compilers spends a lot of time analyzing and processing the program, while relatively little time is spent analyzing and processing the program using interpreters. In using compilers, the resulting executable is some form of machine-specific binary code, while in using interpreters, the resulting code is some sort of intermediate code. Moreover, for compilers, the computer hardware interprets or executes the resulting code, while for interpreters, the resulting code is interpreted by another program. And lastly, program execution is fast for compilers while relatively slow for interpreters. Here's how compilers and interpreters work. For compilers, the source code is being pre-processed or translated into an executable code for the machine or computer. On the other hand, for interpreters, the source code is being pre-processed or translated into intermediate code and then interpreted or translated using an interpreter itself before the codes become executable on the machine. Here's an example of a low-level code versus a high-level code. As you can see, high-level code summarizes the program algorithm into brief and concise codes. It's more understandable and easier to follow. Nonetheless, every code has their own advantages and disadvantages depending on the application that you want to pursue. This time, let's proceed to another basic programming concept, the programming paradigm. Look at the image closely. What do you see? By shifting perspective, you might see an old woman or a young woman. It's a good illustration in understanding the concept of programming paradigm. A paradigm is defined as a set of assumptions, concepts, values, and practices that constitutes a way of viewing reality for the community that shares them. In programming, it is the various systems of ideas that have been used to guide the design of programming languages. It's important to note that programming paradigms are not exclusive since each paradigm has its focus just as illustrated in the image. Furthermore, programming paradigm is a way of conceptualizing what it means to perform computation and how tasks to be carried out on the computer should be structured and organized. Generally, it is classified into the following: imperative paradigm, functional paradigm, logical paradigm, and object-oriented paradigm. Imperative paradigm provides statements such as assignment statements, which explicitly change the state of the memory of the computer. Functional paradigm, on the other hand, express computations as the evaluation of mathematical functions. Meanwhile, in logical paradigm, we express computation and exclusively in terms of mathematical logic. And lastly, in object-oriented paradigm, we associate behavior with data structures called objects, which belong to classes which are usually structured into hierarchy. This time, let's have a closer look with the object-oriented programming. Object-oriented programming was developed because of the increasing complexity of codes for modern programs. It uses objects to design computer programs in which each object is capable of receiving messages, processing data, and sending messages to other objects which have independent functions. Basically, it has four main facets: the abstraction, encapsulation, inheritance, and polymorphism. Some advantages of using objects in programming includes: first, you don't need to understand how they work behind the scenes. Second, you can deploy several objects working at different tasks and division of labor becomes easy. Third, program errors become localized in objects which makes the errors easier to handle. And lastly, the objects are reusable. Now, let's move on to another important concept that you need to know for the purpose of the course. Classes. A class is an abstraction of a real-world concept through a source code. This source code contains the field descriptions or attributes as well as functionality or methods of that particular class. From this source code or DNA, instances of specific objects can be created. Speaking of attributes and methods, when we say attributes, we refer to the pieces of data that describe the object. For example, we have color, name, and size as object attributes. On the other hand, methods defines the things that the object can do or can be done to it. For example, we have set color command, hide command, and show command. We also mentioned earlier the term instances. In object-oriented programming, when we say instances, we refer to the actual object that you use in your program or the resultant in-memory use of a class as an object. This time, let's discuss the features of object-oriented programming. Let's start with abstraction. Abstraction involves the facility to define objects that represent abstract actors that can perform work, report on, and change your state, and even communicate with other objects in the system. Basically, it allows roles and interaction which greatly simplify programming approach. Encapsulation, on the other hand, is information hiding. It is concealing the actual implementation or methods used by the object by using a public interface that determines what is visible to the application outside the class. Encapsulation serves three useful purposes. First, it permits the protection of attributes and methods from any outside tampering. Second, it allows the inclusion of validation code to help catch errors in the use of public interface. And lastly, it frees the user from having to know or worry about the details of how the properties and methods are implemented. Next, we have inheritance. Inheritance is the process of deriving a child class from a parent class. The child class inherits all of the properties, methods, and events of the parent class. It can then be modified or added to or subtracted from the parent class. It also allows programmers to reuse the code they've already written. Another object-oriented programming feature is polymorphism. Lastly, we have polymorphism. Polymorphism means treating one object as another or treating an object of one class as if it were from a parent class. Now, in order for you to understand the things that we have discussed in this topic, I am requiring you to visit and study the following links, for this will be included in your assessment activities and even in your laboratory exercises. Especially, kindly study the Introduction to Python link, which can be viewed in YouTube page. For your assignment, don't forget to do an extensive research about the general programming paradigms and give at least 2 examples for each paradigm. You are free, though, to use whatever format for your written report. Also, for strict compliance, kindly upload your reports in our Moodle classroom. Once again, I am your lecturer for this topic, Engineer Eldon P. De Padua, saying thank you very much and have a productive week ahead. God bless you all.